Find the radius of the red inscribed circle. Label points C, D, E, G, K, and B. Locate the center, O, of the quarter circle. It implies that line O, C equals line O, G, which equals the radius, are of 4 units in length. Join line D, O, and line O, E, each equals to R. Since sectors C, O, D, sector D, O, E, and sector E, O, F are congruent sectors. Angle DOG equals 2 times 1/4 of angle COD equals 1/4 of 90 degrees times 2, which equals to 60 degrees. Line OG equals line OD. Also, triangle DOF is likely an isosceles triangle. It follows that angle OGD equals half of 180 degrees minus 60, which equals 60 degrees. Hence, triangle DOF is an equilateral triangle. Locate center, Q, of the inscribed red circle. Join line Q, B, and line Q, K equals the radius, R, of the red circle. It implies that BQKO is a square. Hence, line BO equals line KO, which equals to R, the radius of the red circle. It follows that line GK equals R minus small r, which equals 4 minus small r. Join line QG. Angle QG, K equals half of 60 degrees, which equals to 30 degrees. By trigonometric identity, line Q, K divided by line G, K equals R divided by 4 minus R, which equals to tan 30 degrees. That is equals to 1 divided by the square root of 3. Cross multiply and we have that R times the square root of 3 equals 4 minus R. Simplify and divide the equation by the sum of the square root of 3 plus 1. We have that R equals 4 divided by the sum of the square root of 3 and 1. Or half of the product of 4 and the square root of 3 minus 1. Hence, R equals the product of 2 and the square root of 3 minus 1 in units. After rationalization of the denominator, required to find the area of triangle ABC. Label points D and E. Let line B, D equals Y and line D, E equals X. This implies that area of triangle BD E equals the product of X and Y divided by 2, which equals to 6. It signifies that Y equals 12 divided by X. We call it equation 1. Let angle C equals beta, which is equals to angle ABD. Triangle ACB is similar to triangle ABD. This is because of side property of similar triangles. It implies that from triangle DBE, using Pythagoras theorem, the square of BE equals the sum of the square of BD and the square of DE. Thus, the square of BE equals the sum of the square of y and the square of x. Take the square root of the equation. We have that BE equals the square root of the sum of the square of y and the square of x. Also, from triangle ABD, using Pythagoras theorem, we obtained an equation for the square of AB as shown on the screen. It implies that the square of AB equals the sum of the square of y and the square of 2, which equals the square of y and the 4. Take the square root of the equation. Thus, AB equals the square root of the sum of the square of y and 4. From triangle ABD, AD divided by AB equals sine beta, which equals to 2 divided by the square root of the sum of the square of y and 4. And from triangle ABD, we obtain two equations which are equal to sine beta as shown on the screen. Equate the two equations since they have equal sine beta. It implies that two divided by the square root of the sum of the square of y and 4 equals the value shown on the screen. Cross-multiply and simplify. Substitute value of y, which equals to 12 divided by x. From equation 1. This implies that the product of 2 and the sum of 2, x and the square root of the sum of the square of y and the square of x equals the sum of the square of 12 divided by x and 4, which equals to 144 divided by the square of x and 4. Open bracket and simplify. Hence, we obtained a new equation as shown on the screen. Cross-multiply. It implies that the sum of 4 times the square of x, 2 times the cube of x, and the product of 2, the square of x, and the sum of the square root of the sum of the square of y and the square root of x equals the sum of 144 and 4 times the square of x, all divided by the square of x. Replace y with x and we obtained an equation as shown on the screen. Remove square root by squaring the equation. Simplify, and we have that the sum of 4 times x to the power of 6 and 576 times the square of x equals 20,736 minus 576 times the cube of x plus 4 times x to the power of 6. Cancel equal but opposite sign terms and arrange terms in one side of the equation. It implies that the sum of 576 times the cube of x and 576 times the square of x minus 20,736 equals 0. By trial and improvement method, x equals 3 is the only real solution of the equation. It implies that x equals 3. From equation 1, y equals to 12 divided by x. Thus, y equals 4. Line A, c equals the sum of 2x and the square root of the sum of y squared and x squared, which equals to 10 units. Also, AB equals the square root of the sum of y squared and 4, which equals the square root of 20 or the product of 2 and the square root of 5 in units. By Pythagoras' theorem, the square of b, c equals the square of a, c minus the square of a, b, which equals to 80 or 16 times 5. Take the square root of the equation. It implies that line B, c equals the product of 16 the square root of 5, which equals 4 times the square root of 5. This implies that area of triangle AB, C equals the product of AB and B, C all divided by 2 equals the product of the square root of 20 and the square root of 80 all divided by 2, which equals to 20 square units. Therefore, area of triangle AB, C equals 20 square units.
Integrate the given trigonometric expression. We need to use the method of substitution to find the integral value of the given trigonometric expression. We begin by assigning a variable to our selected function. In this case, let u be equals to sine x. It implies that du equals cosine x dx. So that we replace dx with the value of du we obtained in the integral expression. Here, we have that the integration of the given expression equals the integration of cosine x dx, all divided by the product of cosine x and the sum of the square of u and u plus 1, as shown on the screen. Simplify to get the u integral expression, as shown on the screen. Then apply the method of completing the square. It implies that the sum of the square of u and u plus 1 equals the sum of the square of u plus half and the square of half of the square root of 3. Hence, we have that the integration of the reciprocal of the sum of the square of u and u plus 1 with respect to d, u equals the integration of the sum of the square of u and u plus 1 equals the sum of the square of u plus half and the square of half of the square root of 3. In general, the integration of inverse of the square of x and the square of a constant term, t equals the product of the reciprocal of t and tan inverse of x divided by t plus the constant term, c. With this formula shown, we use it to simplify our work. In this case, x equals the sum of u and half, which equals half the sum of 2 times u and 1, and t equals half the square root of 3. We have that the integration of the inverse of the sum of the square of half of 2 times u plus 1 and the square of half of the square root of 3 with respect to u equals the product of 2 divided by the square root of 3 and tan inverse of the square root of 3 and 2 times x plus 1, all divided by 3, plus the c, which is the constant term of integration. After simplification of the integrated expression, recall that u equals sine x. Therefore, the integration of cosine x divided by the sum of square x and sine x plus 1 equals the product of 2 divided square root of 3 and tan inverse of square root of 3 divided by 3 times the sum of 2 times sine x and 1 plus c, the constant term of integration.
What is the value of n in the factorial equation? From binomial formula, the sum of n and 1 factorial equals the product of the sum of n and 1, n and n minus 1 factorial. Replace this relation in the given equation as shown on the screen and simplify. We have that the product of n minus 1 factorial and n minus 1 factorial, all divided by 9 factorial equals to 9 factorial. Cross-multiply and we have that the product of n minus 1 factorial and n minus 1 factorial equals to the product of 9 factorial and 9 factorial. By observation method, the closest n value to 9 is 10. Since n minus 1 equals 10 minus 1 which equals 9, therefore n equals to 10.